Okay, so let's go through this question. So for the second part, a curve has this equation fx, right? So where fx is equal to x cubed minus 3 over 2 x squared plus 3 over 2 x plus 7. So we are asked to show that the gradient is always positive. Okay, let's do this part first. Okay, for this part, we need to dy dx first. So the dy dx, of course, I quote your answer. So the dy dx actually you got something like this, right? So dy dx is equal to 3 x squared minus 3x plus 3 over 2. So how do I show that this is always positive? So I cannot just say, this whole thing, right, is more than 0, because this is not showing. To show that it's always positive, there's the first way. First way, I will teach you the first way, then the second way maybe next time. Okay, the first way is actually to do the completing the square. So meaning you take out the 3, you take out the 3 already, right? So what you can do, right, you do the x squared minus x, then after that, plus 1 quarter. Then of course, you plus 1 quarter, you must put a negative 1 quarter plus half. Then after that, you just need to do the quadratic factorization for this part. So this will give you this law. So negative 1 quarter plus half will be about 1 quarter. So next you must expand this 3 inside. So for the inside, so this will give you the answer. So how do I know that this is always positive? Because this thing is always more than 0, or maybe it's equal to 0. So it's more or equal to 0. So 3 times more or equal to 0, then the whole thing plus 3 quarter, right, is strictly more than 0. So that is how we actually show. So that is the completing the square part. Okay, then we are asked to determine why the equation fx equal to 0 has only one real root, and find this root. Okay, this part you will need to use your GC already. So you plot the GC, right? You plot the graph on the GC. You realize that your graph will look something like this. So for example, I plot. Okay, so I draw here. So this is a polynomial. So meaning is here, and then something here. So how do I explain that it only has one real root? Because polynomial definitely must cut the x-axis. So polynomial must cut the x-axis. Then of course I cut the x-axis, right? And there is no turning point, because when your gradient is always positive means there's no turning point, meaning that it will just cut one. But let's just say you got a turning point, for example, I got one turning point. So your curve maybe looks something like this. So you're actually cutting 2 points, for example. So then you just need to explain, because it dy dx is always more than 0, meaning that you cut only 1 point at the x-axis. Okay, the next thing will be I need to use my GC, right, to determine the root. So this one you can plot the graph already, right? Then you press second trace. You press second trace already. Of course, you will see a few things, right? Value 0, minimum, maximum, intersect, dy dx, and integral of fx. So you just press 0. You press second option. Then of course you there's a left bound, right bound, right? So left bound, just do a little bit. The cursor, you just move your cursor a little bit to here. Then right bound, you move your cursor a little bit to there. Then you press enter. There's a gas, right? Then you press enter. So you realize that the root or the x-intercept, right, is about negative 1.33 like that. So let me just do it again. Negative 1.33. Yes, correct. Negative 1.33. So that is how we actually do this part.